Thank you so much, George. And thanks a lot, Irfan, for helping get this all together. We're super excited. I know we're on the dot, so people will keep joining as we continue chatting. But I think this will also be recorded, so you can obviously view this live later. But we're super excited as a company doing our first hackathon. We've been around for 3.5 years now, been building this tech for a fairly long time, and getting people to see what's been happening under the hood is super exciting. Our team has been working, I would say, tirelessly for the last almost 2 months to put all of this together. It's also allowed us to package things in a way that developers can understand Tashi in a much more seamless manner. One of our historical challenges as a company has always been that we've been building deep tech stuff and people don't fully understand the value of it. So today, I just want to take this opportunity to talk a bit more about the history of Tashi, why we built Vertex, what's been happening behind the scenes for all this time, and what's expected to come in the coming months, and then dive into some of the hackathon stuff. Quick history for everybody. We started Tashi about 3.5 years back, and my co-founders and I had been in Web3 for a long time. And the core vision was everything is still run by, despite the vision of Web3 being decentralized, most things in the actual internet run on centralized clouds. And there's a few reasons for that. The number one is SLAs, which means that when you work as a large enterprise, the number one thing you want is a guarantee that everything can run smoothly. And with that in mind, as folks that have been around in this space for a long time, been building for a long time, we understand how businesses work. So the first thing we thought about was that how do we make sure that decentralized technology can actually work with those SLAs around the globe. And when that's how the Tashi idea came about was tech can be decentralized, but how do we make sure the people using it, the businesses we sell to, whoever needs to use this technology can feel sure that this will never break down. You have your 99.99% uptime guarantees. And with that in mind, we started building Vertex, which the core idea was how do you allow people, machines, players, agents, robots, any kind of one in the machine economy to coordinate with each other without having any centralized servers or orchestration in the middle. And we realized there were a few key constraints in that process. One of them was latency, and the second was uptime guarantee. And our dev team is a big shout out to them. Our co-founder Ken and his team that spent the first 2 years pretty much in stealth mode, just doing R&D to figure out all these different concepts and fitting Vertex in the context of all these industry challenges that we were tackling. And we ended up building Vertex, which gets consensus in under 30 milliseconds on average, which is pretty wild when you think about it in context of blockchain and all the other chains out there, say Bitcoin, which was minutes, and then Ethereum, which was seconds, and the fast ones like Solana, which is still close to a second plus, which is great for crypto and for payments. But if we think about real time internet stuff, it is all still super slow. And we put ourselves in the tightest box we could. So we first chose the gaming industry, which is super latency sensitive. Because if anyone over here who's been a gamer, I have been, you realize that you will drop a game the moment there is even a 1 second gap, especially when you're playing a live multiplayer game. And within that constraint, we decided that it was the right sandbox for us to prove that Tashi is a critical tech that can work at scale. And we forced ourselves to say, hey, what's the benchmark that first person shooter gaming typically has, which is around 50 to 60 milliseconds? And can we make sure our consensus time falls below that? And again, like I said, shout out to the dev team that we were able to actually get average 30 milliseconds consensus in small groups of about 32 to 64 players. And from the beginning, when we started this, we knew this is an agnostic technology. It's not just meant for gaming, it applies to a number of industries. But we used gaming as the beachhead for us to prove this. And last year, we thought that we're ready to take this to the broader ecosystems that really needed it. And we started with IoT first, and then got into robotics, and then more recently AI. And the response there has been fantastic because the way we look at the world, and how AI is scaling right now, every machine is becoming an edge intelligent device. And down the line, they'll all become autonomous agents capable of doing a lot of things. Your laptop will have agents running all kinds of things. Your robots will have agents allowing you to do multiple tasks. Same with drones and so on. And as every device becomes autonomous, the key question becomes, how are these devices finding each other, coordinating with each other, making sure that all of the activities they're happening in a manner that it's secure, it's trustless, there aren't any gaps in the coordination, and what the outcome of the expected outcome is from all of those coordinated activities. So that's where we're expecting the world to get to in the next 5 to 10 years, where all of these machines can easily discover each other and coordinate in a trustless environment. And as we thought about this broader vision, when we were talking to some of our partners and looking at these use cases, we realized that there was a lot that Vertex could do that we were, as a small startup, not focused on right now. Because we're going wider right now and we're picking big industries to solve these challenges in, including, say, robotics and drones and so on. But there's still tons of other industries that need consensus in distributed systems. Because as we think about, for folks to think about distributed systems and decentralized systems are separate, right? Because everything today in the way it's structured is already distributed. We're all separated by geography and we're all connected with each other, typically using centralized systems. You can still connect with each other using centralized systems, but you still need consensus in the middle. And one of the factors is that Vertex works in that as well, right? So you have your old school consensus protocols like Raft and Paxos that people typically use to manage state in distributed systems that can be done in a much more efficient manner using Vertex. And as we started getting feedback from our partners on some of these new use cases, we thought it was the right time to kick off a hackathon, because we wanted to put this technology in the hand of hundreds of developers around the world. And shout out to Irfan, who's joined us recently and helped put all of this together in a very short window. And we're quite excited that we've gotten participation from a lot of renowned universities. So we have sign-ups from NTU and US, which are Singapore's two most renowned universities, and I live in Singapore, so quite proud that's the case. We have folks signing up from Caltech and Washington University and HK University and a bunch of universities in India, and we have many developers there. So quite excited that it's a very widespread group of people that are participating. And even before we officially kicked off the hackathon, we had people submitting responses into the hackathon in the last few days. We had to actually hide some of them, and then we only published them recently because now people can actually see them, because now we're officially kicking things off. Quite excited about everything that's come together. To give you a quick sense of what we are looking for and how we're thinking about the hackathon, is the core tech. Vertex is essentially a consensus protocol that essentially helps distributed systems find full economy with each other, where everybody knows what everyone else is doing in a trustless environment. And we've created 3 tracks for people to build and showcase their answers in. And our team has created a couple of README docs and intro docs that help people understand that what is Vertex, how to spin it up, how to create the original peer-to-peer connectivity, etc., that will allow most developers to at least have a good hang of what we are building and what they can expect to achieve in each of those tracks. And then when you go down the tracks path, the idea is to become a lot more specific around the outcomes that we have defined. The reason for that is we have 3 core use cases that we are identified, and we're seeing a lot of progress, and having folks also building in that space on top of Vertex will help move the Tashi vision along. But we've also kept some open boxes where there will be things that people can build, and we will definitely be taking all of those things into account. That is this in line with what Tashi is thinking, or is this in line with something completely unique that we've not thought of and Vertex can solve? and allows us to create some new meaningful opportunities out of in the long run. We've been pretty lucky to get a good group of judges. So we have professors from NTU, from NUS, a couple of other universities, folks from our own ecosystem that are quite tech savvy that will be reviewing all of these. And we'll keep it quite open and very transparent when we award winners for each of those tracks. Hopping into the tracks, so we have the warm up, which is the handshake, right? So typically, if you think about the history, there's two kind of popular ways distributed systems are controlled, right? You have your peer-to-peer model, and as recently as over 10 years ago, more than half the internet used to run peer-to-peer. That's the BitTorrent days and the Napster days where everyone was sharing files directly with each other. But as the cloud companies became more ubiquitous and AWS, Azure, and all these guys came in, we moved to a more centralized cloud orchestrated model, which is more client server. So what we've done is gotten the best of both worlds. So it runs peer to peer, and that's why the warm up track is just finding the connectivity between two peers, and the consensus runs in the backend. And that's what our team has built and allows us to happen is that it acts as the security layer on top of the peer to peer network, which solves the problem that typically most peer to peer systems had, which is how do you trust the other person if you don't know them? Moving into track one, what we call ghost in the machine. This is the idea here is that we are moving into a world where all, like I mentioned, all devices are going to become autonomous. So from robots to drones to all the IoT devices. If people over here are old enough, you'll remember 10 years back, one of the hottest things everyone was talking about was smart cities. And I'm based in Singapore, which is quite the bubble. And the goal was, how do you make all these cities into smart cities where everything is interconnected? And people realized there were tons of challenges to make that happen. Even smart buildings, which was like considered one of the hottest things that people were saying, hey, this is a smart building. Even that didn't become a full reality because all the tech stacks that you have on different devices operate in silos. And the goal for us, as we're building this tech, is how do we have interconnectivity between these devices at scale without compromising data sovereignty. And that's one of the key parts of this track is you're building with any kind of paradigm of devices that have some kind of autonomy because everything can run agents or some kind of model on top of it. Or if you're running just smart devices, we have our own MQTT protocol based product called Fox MQ. And I'll just talk a bit more about that later. But the goal really is how do you make sure that all these different devices can coordinate with each other without having semi-centralized orchestrator. So anyone building something that's a cool use case or a demo in this space is going to be quite exciting. I'm sure there's tons of things that we've not thought about that some of you guys are already thinking about. The second one is what we call search and rescue swarms. Right now, drones have been getting a lot of excitement globally, especially because of their use case in the wars that have broken out recently. Ukraine proved in the first place that drones are critical in their efforts, and same is happening with Iran right now. And people are, because of that, focusing a lot on drones. But drones as a tech or as a hardware piece has been being innovated upon for a long time. And there's a bunch of other use cases outside of defense that are people use drones for. Like the number one use case for drones is actually agriculture. People use it for mapping, for a whole lot of things. And in this case, we thought about the search and rescue swarm. And the reason for that was that even though data centers are becoming ubiquitous, you don't have internet everywhere in the world. And devices have their own capability to connect with each other and have intelligence on them. It's like Apple is trying to make sure that they didn't get into this whole build the data center model use case because they are building the next generation of devices that can run all these models locally. And as all these hardware specs are getting significantly stronger, you will be running a lot of these inference-based models locally. And what then you need is that if you're running your AI on your local device and you still need coordination, you don't necessarily need to connect to an internet or a data center anywhere nearby. And so what we call search and rescue is, you can think of a scenario, and we even have one. If you go into our YouTube, it's one of our demo videos out there, and you can find that we've did some simulations around this where a ton of robots and drones are going into a forest to find a missing kid. But if you think about that, it applies to multiple other scenarios as well, right? You would be sending these drones into any remote environment where they essentially lose internet connectivity, that there isn't any connectivity with anyone, but they can still connect with each other. And the reason why that interconnectivity or intra-connectivity between those, say, drones is important is that one drone, say, imagine there's 10 drones going out on a search and rescue mission. Drone one spots something, it should be able to send information to the other nine guys, because it impacts how the other nine robots, these other nine drones, will do their decision making. Same applies for if you're doing mapping related stuff and something new pops up, you're essentially sharing live intelligence with everyone. And that impacts how fast and how quickly things move in that ecosystem. So anyone that builds something in this space, think about where you're sending, say, any kind of, it could be drones, it could be robots, but you're sending them in remote environments. You could have examples where what happens if some of these devices shut down. You think about, they get drones flying into an environment, say in a war zone, five have gotten shut down. How do those drones self-heal and become a swarm again? Or if they're in a tough lane, they bang into something and essentially break down. How do these other drones take up the task of the drone that's not around? So all these kind of scenarios play out when you put devices in a real world environment, and they need to allow themselves to be figuring out what the other device is doing. And on the basis of that information, does the mission change, does it evolve, how does their thinking process evolve? And that's the goal around this. Moving to the third one is the agent economy. So we have obviously, like, one of the things we talk about is that robotics has been around for a long time, and people have been building in this space for a long time, and some of our partners have invested billions of dollars in this space. But it's gotten so much attention recently, and the number one reason for that is AI models on robots have just become a lot more efficient. And the next evolution of these models is AI agents. So it started with tons of companies building things out. Manus has one, which is a company that got acquired by Facebook. But globally, agents started blowing up with OpenClaw, which started off as ClaudeBot and now is OpenClaw. And you have everyone trying to build their next version of agents, with Perplexity launching cool ones and people running them locally on clouds. But if you think about it, this is still quite nascent right now. It's a new world that we're building into, and these agents will start becoming ubiquitous in the next couple of years. So right now, it's, I would say, 0.001% of the world population is probably running an AI agent. And if you think about 5 years from now, that's probably going to be like 5 to 10% of the world, or even higher. And that's the world that we're trying to build into and solve for. And if you think about the future of having, say, billions of agents in the world, the question becomes, how do you discover the right agent that you need to connect with? How do they coordinate with each other? How do you ensure that the agent is trustworthy on the other side? What kind of data is being shared? Where is that being stored? Multiple things happen. So we have tons of partners that we're working in this space with that are solving some of those problems. For us, it's more about discovery and coordination at scale, and doing that in a trustless environment. So the goal really is that, how do you discover agents at scale and coordinate tasks and make sure that they're happening seamlessly? We obviously realize that you guys are putting in a lot of effort into this. We are, for everything, obviously have a prize pool. So for each track, there is a prize that will be awarded by the judges in terms of folks who win these tracks, but also for the effort, right? Because we recognize that you're all seasoned developers that are signing up. So for every day building something, there are prize pools that have been identified. There's daily awards that we will be giving out to developers that will get awarded to folks for all the efforts they're putting in on a daily, weekly basis as well. Some of them come in from in the cash form, some come in from a voucher form, some will be in the future Tashi token form. Some of them are in the form of us connecting with you with a lot of our partners. But the goal really is that for any effort that folks are putting in, they will definitely be rewarded. We will also obviously look at anything that's super meaningful and it can become a potential product for us. There will be things that we can do that will be beyond these reward pools. So don't restrict yourself to what you see over here. If there is something that somebody builds that can almost become like an alpha product or allows us to say, hey, you build something that's a lot more meaningful that we can use, our team would be looking at that very closely, and we will look at rewarding you and potentially even hiring you. So there's multiple things that can happen that are outside the scale of what's defined within this. So think like what Anthropic CEO says with AI. Now your limit is the human imagination. You guys can go wild and free. When you think of some of these things, go beyond what's written. And for sure, all efforts will be recorded and rewarded according to what's actually creating value. So yeah, with that, I think there's obviously a bunch of links that you have in Dora Hacks. You can go in there. That has our FAQs. It has the links to our GitHub. Our team will have regular check-ins, so we'll always be available to help solve and troubleshoot with you guys. We're quite active on all the channels, on X, on Discord, on Telegram. Discord and is going to be the main place for all technical stuff. So wherever you face any issues, feel free to ping them there. George, who's our main man when it comes to this stuff, is fantastic when it comes to solving tickets. We've had a few in the past, as we've also built a deepin which has over 60,000 node operators. And as you can imagine, when you're running a network at that scale, sometimes things don't go as well. We are always looking out for our community and want to make sure that all issues are resolved. So we're quite excited about this, and thank you so much for everyone who signed up, and looking forward to seeing what comes in.
There you guys go. There's your intro. And by the way, you don't know Amar like I do. This is the most excited I've seen him in a while. He really means all this. He's like the chillest dude ever. So, yeah, him smiling this much, he means this. He's really excited about this hackathon, as all of us are. Thank you, Omar. Awesome intro. Yeah, I think you guys should just know that we are very grateful for everybody here. We see you keep joining. We really appreciate that. And yeah, just as a personal note, stop running nodes, guys. 60,000, chill out, right? There's a lot of work. You guys are insane, okay? We've gone up like 10,000 nodes a day at some point. So yeah, keep growing the network. We really appreciate you guys. Everything Omar says is exactly true. Reach out to us if you need. Go into the Discord, and we really look forward to the stuff that you guys are going to be building. A couple builds have already come through. Let's not slow down. We're super excited about this. Hopefully to help you guys out a little bit more in a little bit of a more of a technical type of a breakdown, we're now going to go over to Divy, who's one of our software engineers.
I've been working with Tashi on the forefront of Vertex as well as Fox MQ. I've put together a couple of starter templates for all of us to get started with the hackathon. In this quick walkthrough, we are going to take a deeper dive into the arc of Vertex as well as Fox MQ. It will give us context about what we should choose based on the projects that we are going to be making on top of this and get started. So let's look at the blueprint of a swarm. Leaderless distributed arc built on Tashi Vertex consensus. Layered system design, where the network layer consists of peer communication via QUIC, consensus layer is Vertex Hashgraph engine, service layer use system like FoxMQ, and the application layer uses user applications. Each node participates equally in the swarm. There is no centralized coordinator or the broker. Fragility of the center versus swarm. Traditional system relies on centralized brokers or servers. Centralization introduces single points of failure. Swarm Arc uses peer-to-peer mesh communication where nodes directly exchange events. The network maintains a globally synchronized state through consensus. Because the system is leaderless, failure of individual nodes does not bring down the network. Virtual voting. Hashgraph eliminates the need to send explicit vote messages. Nodes exchange events through gossip. Because every node eventually sees the same event graph, each node can compute how other nodes would have voted. Voting therefore becomes a deterministic local computation instead of a local network communication setup. This significantly reduces communication overhead and improves scalability. We have node A, Alice, and node B, Bob. Right now, there is zero voting data sent over the wire, but Bob is able to locally calculate Alice's vote based on sheer knowledge. And we have the metadata of max throughput and latency via virtual voting. Let's look at the life cycle of the truth across the network. Each transaction follow deterministic life cycle inside the network. First, it is created. A node creates an event containing transactions. Second, it is received. The event spreads to peers through gossip. Third, event graph formation. Each event references two parents. Self parent is attached to previous event created by the same node. Other parent is attached. Latest event received from another node. These references form a directed acyclic graph of events. The fourth state is accepted. Virtual voting determines whether the event is strongly seen by a supermajority of nodes. Fifth, finalized. Over two-thirds of witnesses agree. The event becomes finalized and enters the deterministic global order. Autonomic network health and dynamic rate budgeting. The network regulates throughput automatically. Transactions are batched into events before being propagated. QUIC flow controls, manages bandwidth and connection stability. Consensus round also enforce byte budgets to limit the amount of data propagated in each round. The prevents and keeps swarm stable under heavy load. Tashi Vertex. What is Tashi Vertex? It is the core replicated state of machine engine. It implements hash graph consensus using a DAG event graph stored in an optimized in-memory event store. Each event contains creator identity, parent references, ancestor bit masks, consensus metadata such as round and witness status. Events propagate through network using QUIC gossip. Consensus is determined through virtual voting. The arc is determined for extremely high throughput. Fox MQ is a decentralized messaging system built on top of Vertex. From a client perspective, Fox MQ behaves like a standard MQTT broker. Internally, each published message is converted into a published transaction. This transaction becomes the payload of a Vertex event. Consensus ensures that messages are globally ordered across the network. The broker is the swarm itself. In traditional MQTT system, a single broker manages message routing. If that broker fails, communication stop. In FoxMQ, the swarm itself acts as a broker. Any node can publish and accept request. The message becomes a Vertex event and is gossiped across the network. Once the event is finalized by consensus, each node delivers the message to its own subscriber. Let's see at the integration part what you should choose for your project. There are two main ways developers can build on Tashi ecosystem. Vertex provides the raw replicated state, machine, and consensus engine. It allows developers to build custom distributed protocols and applications. FoxMQ provides a higher level messaging abstraction. It exposes an MQTT compatible interface while internally relying on Vertex consensus. If you were to build Unity Physics Spatial Agreement or a custom ROS True Drone controller, Tashi Vertex should be your choice. If you want WebSocket CI dashboard, IoT telemetric streams where you are using something around pub/sub messaging, or you want to have standardized MQTT sort of setup, you need to go with FoxMQ. In the end, one decentralized reality. Both Vertex and FoxMQ operate on the same swarm infra. Vertex give developer low-level access to the consensus layer for building new distributed system. FoxMQ provide a ready-to-use decentralized messaging platform. Together, they enable system where the network itself act as a shared infra rather than relying on centralized servers.
All right. That was Divy. Huge thanks to Divy for doing that for us. Strategic little intermission there. Clearly, you guys needed some time to join. We're up by 50 other viewers, so that you guys are welcome for that little interlude for you guys. Just giving you guys a chance to catch up. Hopefully, that was helpful for everybody. Again, I know it's a bit of a technical topic. We're introducing you to some new tech. This is tech that has been new to us in the last month, to be honest with you, that we're still working with, that we're still discovering all the possible applications for. So again, you will have access to all these resources to go back and rewatch them and dive deeper into it. If you guys have questions, join the Discord. There's 10,000 of you in there now. We're hoping to make that 20,000 very soon. So get in the Discord, ask your technical questions. More than happy to help you guys out. Just start building. We start building, we'll answer your questions, we'll hold your hand the whole way through. We just want you guys to get out there and start building because we really believe in what is happening here and all the applications that will come out of super smart, awesome communities like we have with you guys, just picking up the tech and building the future that we all see right now. So, without further ado, now we will go ahead and bring up Dhanush, who's our other software engineer, who will give you guys some more detail and then hopefully run you through some demos that will give you some inspiration or maybe some other context for what it is that you guys want to be building.
So let's start by understanding how to get consensus engine based on hashgraph algorithm right out of the box using the Vertex Rust library. So in this demo, I'll walk you through how to set up three-node consensus network where each node has its own cryptographic identity. They all connect with each other to submit a transaction, and they all receive it back in a consensus or a sequence. The heavy lifting for all of this is primarily done with the Rust library, which is the library for Vertex. The prerequisites is to have Rust CMake to build the whole project. You can add the library to any of your existing Vertex project. That is as simple as adding it from the crate. Now, the primary objective of every node is to have an identity, and every node in the Vertex network has one, and it is based on a cryptographic key pair where the secret you send, the events which are transmitted, uses these secrets to identify. The public key is how other nodes identify you, and both of these can be printed using the key generation example that is over here. So once you run this, gives you two keys, which is the secret key and the public key, which is the identity of this first node that is going to be on the Vertex network. Now you can generate multiple of these keys, like they are how you can add more nodes into the network. And whenever these secrets are used to communicate with each other, they are identified as a separate node in itself. Let's start with a hello world example over here, way these cryptographic nodes identify themselves. So here, this shows the secret pair, the key secret of your node's identity, the context, like where the runtime which manages the IO and resources has been initialized, and the initial heartbeat, which is the latency and the epoch sizing to show that the node is ready to accept requests and transmit events as well. So to put it all together to showcase the demo of the three nodes talking to each other and reaching consensus, I've created this small script that primarily configures the nodes to listen to each other over localhost, binding it to a specific port. And there is the membership list, which is created, and Vertex handles that internally. And then finally, the creation, the starting of the engine itself, and the sending of the transactions, where a ping is sent and it is submitted to the engine, and the transaction gets wrapped into a signed event using the key pair which we created earlier and gossip to all the nodes. Let me just run the script that I've created to automate the entire creation of nodes and the communication process, and then we can go step by step into the output and dissect how it works. So the first and foremost, the primary one is to creation of the nodes itself. Here we are showing the public keys of it, which is how they're discovered and verified. Then each node is then binded to a specific local port, and the next immediate aspect of it is when all the nodes initialize their runtime and join the consensus engine, which happens over here. And the first initial message, which is the syncing of all the nodes, happen independently when the engine is started. The first sync point marks the beginning of a consensus session that all the nodes see. Then you have the actual final consensus event itself, which is the broadcasting of the message of the nodes, which has who is sending it, when was it created, when the consensus was reached, and finally, like the message itself. So the key takeaway over here is setting up nodes, which form the basic infrastructure of Vertex, and showcasing how nodes identify themselves and each other in the Vertex network, and then finally how messages are passed between the nodes and how consensus is achieved.
All right, now we're just giving you guys a little bit of a break again. Hopefully, it's all digesting and makes more sense to you than it does to me. But this is I know we know that this is pretty highly technical information being given. So if you guys have questions, if you guys need some time to process all of it, write in the
By
comments
now, you
below.
will know about what Fox MQ does and how it leverages the Vertex consensus underneath. So in this demo, I'll walk you through how to set it up and how to use it in your favorite languages. The prerequisites are any programming language that has an MQTT library to connect with, and the Fox MQ binaries. So select the operating system that you're working with and download the binaries and unzip it. You will be able to run the binaries immediately. You can see the commands with the help section as well. The first thing that you have to do once you download the FoxMQ binaries is to create an address book. So the address book says all the users and nodes that are present and discoverable by each other. So in local, we can set up one address book, but but in practice, it's always best to create multiple ones for better consensus mechanism. I already have it set up. So the address book creates two files, which is the configuration file of the key itself, and you have the private key, which you can use to verify and sign events. The once you run FoxMQ, you can add users into it. The users can be allowed to connect without any credentials with the allow anonymous login flag, but in production, it's recommended to give it a username and password to connect to. So the first step is a simple one, which is you run FoxMQ and then you're able to connect it with just two lines of code using any MQTT client library. Now, I have a simple small publisher receiver demo which I'll run that basically showcases how FoxMQ runs and how the client connects to the FoxMQ broker. and how a node can be spun up and how a message from that node can pass to another node in the network. So let me just run the FoxMQ broker and we will dissect what is happening over here. The primary one is, of course, the initialization of the FoxMQ broker. And first we have a message that tells that FoxMQ is connected and it is running on the specific port. The first thing is the publisher, which is sending a message with timestamp, and it is waiting to be run through the Vertex consensus stage, and then finally it is received by the second node, which acknowledges the topic, the message, and the timestamp itself.
All right, now we are through 2 out of 5 main talking points. Now we're gonna move into the AI track demo. For any of you guys interested specifically in the AI track, this is probably for you.
So
Go
let's
ahead.
look at some actual use cases. So in this technical implementation of something called as Nexus, that is an high frequency agentic commerce implementation, we have used both Vertex and achieved a similar conclusion that we have done with FoxMQ as well. I'll walk you through both of them and then we can see how it is different in the way the data is transported. Primarily, the objective of this application is to simulate how advertisers and publishers bid for ad spaces, and not in small scale, but in micro ads and high frequency settlements. So basically, the advertisers have a bid and the publishers have a minimum pricing. They all send their requests into the consensus mechanism, and there is a resolution that happens where the winners ad space, and there is a settlement that happens in the clearinghouse. So all of this is recorded within the consensus. So now both of them, the whole concept can be implemented by both Vertex and FoxMQ. The difference being that Vertex directly sends and receives the transactions, but using FoxMQ, you can abstract that whole process by using an MQTT broker that publishes and subscribes to, and FoxMQ internally handles the consensus. Let's quickly run the demo so that we can see how the whole process works. This quickly showcases how you actually can visualize the ad subscribers and bidders trying to get ad spaces and sellers. And you have this in real time and the number of deals and transactions. Of course, the process itself is simulated, but you can quickly replace the simulation with an actual LLM call that in real time is bidding for ad spaces and using consensus on Vertex as a mechanism for record, for cost cutting, and decentralized approach of conducting this action as well.
Yeah, if you guys are actively enjoying the demos, again, leave comments and leave questions if you end up having any. This is one of the first times we're ever doing live demos like this of active working product like this. So if you guys have any questions or you want to know more, please, it can be now, it can be later. We'd love to help you out. We just want you to
So now
build.
we come to the interesting part of the track, which is the simulation of hardware. As you can see, we are using VBots, which is a tool to create environments and add robots, drones, but also connect it with a backend interface like Vertex. So let me walk you through our warm-up repository that creates a template for you to clone and get started with this environment of two drones who have to have a handshake procedure to start their mission using Vertex. All you have to do is run the setup script that is given within the repository. What it does is it links the Vertex library and creates a swarm configuration for the node for the two drones to have a successful handshake. So let's just reload the environment. And as you can see, similar to how you would register a node in the Vertex software side, it is similar over here as well. The drones register as a node and they have their own identity and they're initially getting part of the consensus. Once they are into the network, they start a handshake procedure where each one acknowledges the other node, and finally they switch. When one of the nodes switches its state to mission mode, it automatically is gossiped across the network, and so does the second drone, proving consensus. So you can build a lot of things with VBots and the Vertex configuration. The repository is public, so you can clone it and build awesome things.
Yep. Moving into our final demo now. Dhanush has put a lot of work into this. If you guys appreciate it, thanks. Say some thanks in the comments. He's done a lot of work with this. Again, if this inspires you to do something, if you have an idea that comes out of this, if you have a question that comes out of it, always let us know. We're community building first. We want you guys
Let's
to
now
use
look
this
at
stuff.
another demo that we have put together to showcase what you can build with Vertex and VBots. So this environment in VBot showcases some rovers that have been set up inside a very hard terrain, and they've given wheels so that they can move around. They all have sensors, cameras, and they have the ability to move. But whenever they're moving, they transmit data through the ROS protocol where they're sharing information at all times, sensor data, accelerometer data, the camera information. Now, we have also integrated consensus through Fox MQ, where it, the rovers share state at all times to check upon each other, their health, what they are seeing, what is the what phase of the map they are in, to create better mapping systems, or in general just understanding the status of we run all the let's just run the so this script technically starts all the FoxMQ brokers and the individual bridge nodes as well. So you have the camera starting up, you have the entire accelerometers, LiDAR, and each of the nodes are communicating via ROS2, and finally being settled on the consensus network between the individual rovers. Once all the modules are up, the consensus is complete and it starts to emit information with each other. So as you can see over here, we have 4 broker nodes with some supervisors, a few bridge nodes, and finally the cameras, the LiDAR bridge, and exploration nodes for the path planning, and finally the consensus handlers itself, which are the vertex nodes. So we can quickly spin up the consensus monitor that monitors the state of the nodes and what they are up to. As you can see over here, it shows in real time the health, the what are all the capabilities of the robot in terms of odometer, camera, and where they are in the entire map itself.
All right, that was Dhanush with our very detailed, thank him for that, very detailed demonstration. I hope you guys enjoyed it. Clearly you did, because the number of viewers keeps going up and it's been an hour. I don't know how you guys are still here. Hopefully we can wrap this up for you soon, because I almost feel bad for you guys at this point. But thank you for being here. Thank you for your commitment to all of this. And look, honestly, we just really look forward to what you guys end up building with this. So now I think it's time for us to go ahead and give the room back to Amar, to give him a chance to wrap us up, give his final thoughts, give his vision for the future, let's say that, and potentially answer some of your questions. And I know we've thrown a lot of information at you guys. So if you guys have questions, ask questions. Omar will happily weigh in and answer them. If you want to rewatch this and then come back to us again, the Discord is open. Let us know. We'll happily help. We'll happily bring some of the guys you just heard from in to make sure that you guys have all the tools you need to use this tech that we're so excited for. Amar, floor is yours, my man.
Thanks a lot, George, and thanks a lot. Shout out to the rest of the team. I can assure you, everyone's been working tirelessly over the past few weeks to put this together. The goal has always been, how do we ensure that this tech can be used seamlessly? So we've been, like, I think as you guys know, been building for 3.5+ years now. And the next evolution of this will be productizing some of this stuff. So you have the base Vertex layer, and we'll start building products on top for each of the verticals we're focused on. And that's the part we're quite excited about, and the team is quite excited about. But as we move into that world, the goal was, how do we bundle this technology and allow people to use it seamlessly? Because one of the challenges we've seen ourselves in the past couple of years talking about this is that this is a new paradigm, and new paradigms require people to become aware of why we build this, how it works. And so we're trying to do our best to make sure that we can educate our audience, which is all of you amazing developers out there, to understand the thinking behind this, as well as to try and automate some of the early simple tasks of doing the handshakes, building, spinning up the nodes. Our team was working to make sure that everyone can do at least the core tasks quite seamlessly. So there's obviously a lot of technical concepts that we threw at you guys. So if there's any questions, I'm more of a business person. So wherever I can, I'll help answer them. Otherwise, our team is also here on the call. They can hop in. If any of you want to share the questions later, don't need them answered immediately, feel free to raise a ticket in Discord, send them our way at any point of time. We'll keep doing weekly sessions around this as well to make sure all the questions are answered. You can raise them later and send them our way as well. So we're around for some time, for the next 10 minutes or so, to answer anything live that you guys would like. But as George said, the number of viewers is going up, so we feel quite excited that this message is resonating, this tech is resonating, and there's more and more folks showing up that want to build with us. Quickly, some housekeeping and Q&A. So for anybody who's interested, you have to officially sign up via the Dora Hacks link that's there on our X, and your email is mandatory because it allows us to communicate with you. You can find all the documentation on our GitHub. So we've created a hackathon guide within the GitHub that gives you all the details that you would possibly need. You can sign up for our Discord community. Our email for any support is hackathon@tashi.network. So just drop us an email in case you're not joining any of those channels. And we will also do weekly 1 hour sessions where we'll just hop on, talk a bit more about our updates, and just troubleshoot live. So me and the devs will be online here just trying to make sure that you guys aren't getting stuck. And if anyone is, we can help you guys out. So today is our official kickoff. So that's what we're kicking this off with, is this webinar. So anyone that's interested, please sign up on the Dora Hacks link. And the last submission will be on April 6th. So we'll be running this for the next few weeks. So you have a few weeks to continue building across the tracks and submit by 6th April. Post that, we'll bring in all our esteemed judges to review everything. We will try not to take too long. We'll try and wrap it up soon, and we'll announce a date as well. We have a few more partners that are interested in joining us. We'll announce a final session where we pick the winners and announce them publicly as well. So that should be an exciting one. And we'll announce the date for that in the coming days as well. In terms of how to win, we have an attached doc within the Dora Hacks Plus. You'll find it on our X. There is a few things, obviously, in terms of the prizes that we've spoken about. And there's a few issues that if you help highlight, you will earn some rewards for that. So all the things you'll find within the FAQ section. So feel free to review all the material in there. And we're all there to help you guys out, to make sure that we're working together to get you guys to build some exciting stuff and also troubleshoot so that no one stays stuck for a long time. So super excited. Thank you everyone for being here. This has been fantastic. I'm glad that everyone was joined for a short window. George, let us know if there's any questions that are popping up already.
I think I am seeing a couple questions that I will combine into one for you, just for brevity's sake. But I think, and I think this is probably the best question here, is we've shown a lot of general use cases, some of the really technical stuff, what they potentially could do. But obviously you're working behind the scenes, you're the face of this, you're driving this stuff forward. What is the use case that you're at least in talks now, or is in the process, maybe behind the scenes right now, that you think you're the most excited about, that Tashi is moving into? And I think the combination to that is, what direction, which track and which direction are you most excited to see some of the community guys build into? Obviously, there's going to be a lot of exciting stuff, hopefully surprising us as well. But yeah, give us your thoughts on what you want to see out of the guys and what we're currently working on that maybe the community isn't all that aware of yet.
Yeah, so the first part of that is easy. So very happy to share where we are across those use cases. We're the most deep down the rabbit hole in the drone swarm use case. We have pilots with a couple of fairly large players who are hardware plus software guys building drones for defense tech, supplying to fairly large sovereign countries. These solutions, as drones have just become a critical use case. We've done tons of simulations thanks to our internal team to showcase why running Vertex behind the scenes is quite critical, and how our mesh networks are quite amazing when you think about using these drone swarms in live environments. The next step that we are doing with some of our partners is running these drone swarms in live environments. So what that means is moving from simulated worlds to running them on actual drones in environments where you see the drones flying around, coordinating real time, having, say, one of the drones facing an issue and self-healing in terms of the swarm and continuing its mission. So that should be happening quite soon. So we'll obviously publish any results as we see them as well. And that's the furthest along that we are in. The second one, which is the robots in warehouses, we've done tons of simulations with some partners. We're trying to lock in some live pilots. So those are in interesting conversation states with a few of our partners right now. So we expect that to happen in the coming weeks as well. In terms of size and scale, we feel like that's probably what's going to become pretty big in the coming months, because in general, there is a massive amount of investment going in the robotic space. One of the companies I worked at, Uber, the founder there, Travis Kalanick, just announced his new gig called Atoms, which is about robotics automation. And we know how that guy thinks. That's just one of the many in Web3. CZ just invested in one called RoboForce. Everyone across the field is going deep down this space. And as we think about robotics becoming ubiquitous, coordination is a key challenge. So we feel like this is going to scale up. The third piece around AI agents, I think they're still in the discovery phase of how these agents are going to scale. We're quite excited about what that world will look like, where every device has an agent running on it. But there is still a lot of monetization that is yet to happen. So even with things like OpenClaw, I had to ping Dhanush on our team and ask him a few security questions before we could spin up our own and run a few. And companies are trying to productize this stuff, but there is still many vulnerabilities in terms of how these agents are hallucinating depending on the models or doing things they're not supposed to do. And when you think about this tech becoming ubiquitous, it's still needs a lot of that polish. In the long run, I think that's going to become the biggest part or the biggest ecosystem when we think about how software is going to scale. Everything will be agentic. So I guess our core thoughts would be drone swarms is where we're immediately focused and we're quite excited by. So any things that we progress on with things that come in on tracks, we'll be excited to see how you guys are thinking about this use case. Robotics swarms is where we feel like we will scale quite soon in this year. And on the agentic side, it's more, I would say, blue ocean, right? So we're figuring it out along the way as you guys are, and all submissions in that space will just allow us to learn more and build more. And I think it's just such a fun collaborative space that is going to blow up in the coming years.
You guys have it. I think that's probably going to be it for us on this stream. We were planning to go 45 minutes. We're half an hour over that. We're hoping you guys enjoyed it as much as we did, because yeah, we're genuinely really excited to be doing this. This is our first hackathon, hopefully the first of many, that will also go on to include more of our amazing partners, the whole ecosystem. We're really looking forward to be in this stage now where we're actively building. We're giving you guys the tools to actively start building. We're giving you guys the ecosystem to actively start building. And we just want to do this thing right. We want to do this thing together. So thank you for joining us on this one. It's definitely not the last hackathon, and it's definitely not the last stream of this type that we do. We actively plan to talk to you guys more often, bring you more updates, bring you more tools, and just get this thing off the ground exactly the way that it has been in our head for the last 6 months, but it's finally getting on paper and it's finally getting in your hands. So thank you guys. We really appreciate you guys joining us. I'm bringing Irfan on stage here as well. Give us some final words of wisdom. Both of these guys are much smarter than I am. They just let me talk because they feel bad for me. So Irfan, close us out, my man.
You're on mute.
All right, so good. Thanks to AI, it showed me that I'm on mute, right? So even while I started. So yeah, thanks, George, and thanks to Amar. I think you guys are on top of everything. I think before we wrap, I'll just remember this is a live and collaborative challenge, and to get the most of it, I should just keep three things in mind, right? The first is built in public. So whether it's a breakthrough or a failure that you're doing, share it across social, Discord, X, using our official hashtag, which is the Tashi Vertex Challenge. We are actively watching it. We will also be featuring these teams. We'll also be giving them weekly bounties. Second is we are here to unblock you, right? So if you get stuck anywhere, just drop your questions or the demo videos to us either on Discord or email or set on hackathon@tashi.network. We have a dedicated team that's living on these channels. So we are here to help you and solve you. And finally, it's don't wait for the weekend. Go get your first award today. You can easily spin up 2 nodes and claim the today's $50 bounty, right? So we'll be giving away $50 prizes, simple for handshakes every day. So go get it, right? And we can't wait to see what you're going to build, right? So looking forward to it.
I told you he was smarter than me. I'm out here trying to motivate people. He put cash behind it.
Yeah.
You can't teach experience.
Yeah.
All right. Thanks, guys. Really appreciate everyone who joined. Really appreciate anyone who's watching the recording of this. We appreciate you just as much. See you guys. We're checking out. Don't get lost. Get in the Discord. Build some cool stuff.
Thank you, everyone. Appreciate it.
Thanks, everyone.
Bye.
Cheers. Bye.